Okay, so this is problem from section 10.2, problem number 8, question number 8. As you can see here, this is the data we have given: distance, time, fare, and tip. And we would like to find out relation between time and tip. Use the time and tip data, time and tip. So we're just going to use second and then last row. Use the time and tip data from the table below, which includes data from Newark taxi rides. The distance are in miles, times are in minutes, the fares are in dollars, and the tips are in dollars. Find the regression equation, letting time be the predictor variable. So x is a variable. We would like to find out the regression equation of line, which can be used to correlate time versus tip. So x is time, y is no, x is the time and y is the tip. Okay. So now after that, find the regression equation and find the best predicted tip for a ride that takes 30 minutes. How does the result compare to the actual tip amount of 4.7? Okay, so actual tip is 4.7 for 30 minutes. But based on this model, if we would like to predict, then what would be our prediction for 30 minutes rides? That's what we would like to find out. First of all, let's find the regression equation by using a calculator. Where is that? Okay, so if we use a calculator, then we have to first use this data, time and tip. Time is our x value and then tip is our y value. So go to stat number 1, and that will give you the place. L1 is the list of data for time, and then L2 is the list of data for tip. Okay, I'm going to type this value here: 27, second one is 18, third one is 11, fourth one is 8, 2, again 8, 31, and then 25. That's our uh, the time. For this 27, the tip is $0, and for 18 minutes, the tip is 4.29. 4.29. So this is actual data. So we're just going to use this actual data. For 11, the value is 1.96. For 8, it's 0. For 2, it's again 0. For 8, another 8, it's a 2.34. That's the tip. For 31, it's a 2.98. And for 25, it's 1.5. Okay. So this is the data. We can find the regression equation by going here, go back here, this is stat, and go to test. And if you go down A, B, C, D, E, linear regression test, just hit enter here. That will give you the X list is coming from list 1, the Y value is coming from list 2, frequency is 1. This is always not equal to 0, and just hit calculate. It's going to give you the equation y equal a plus bx. That is our linear regression, the regression equation. Here instead of y cap, we have y. The a value goes here and b value goes here. As you can see here, a is 0.90, and here we would like to round to the 4 decimal places, so it's a 0.9043. 0.9043. And for the b value, go down, and it gives you the b value 0.0449, 4 decimal place. Okay, 0.0449. So that's our regression equation. What happened? Let me just go back and check the value one more time. It's a 0.0449. It's b of x 0.0449. Is 0.9043. That's supposed to be right. Round the y-intercept to the 2 decimal place. Sorry. Okay, the y-intercept means this value should be 2 decimal place. I use 4 decimal place, so I have to you know retry it. It's a point. What is that? uh, this value is fine, but y-intercept, what is that? Round the y-intercept to the 2 decimal place. Oh, okay. The y-intercept means this value has to be 2 decimal place, so it should be 0.90 only. Okay, so I did not read the instruction clearly, so make sure that you have to read the instruction for rounding here. They say, this constant number, which is y-intercept, has to be 2 decimal places, and round the slope. Slope means the number in front of x is the slope, that is 4 decimal places. So that is our regression equation, and now we have to predict how much step uh, will be there for the right 30 minutes. But remember, to make that prediction, you have to, this problem should satisfy some of the situation. You cannot just use this regression equation to make the prediction. So I'm going to show you when that can be, we can make the prediction. To make the prediction, the model you're using has to be good model, not the bad model. Okay. So regression equations are often useful for predicting the value of one variable given some specific value of the other variable. When making prediction, we should consider the following. Bad model. If the regression equation does not appear to be useful for making prediction, don't use the regression equation for making prediction. For bad models, the best predicted value of a variable is simply sample mean. Okay, so what they are saying here, it says, hey, first of all, before making the prediction, find out either you are using bad model or good model. So how do you know that it's a bad model or good model? Okay, so if it's a bad model, somehow if you found it's a bad model, then instead of using this regression equation, we use sample mean to predict the value. Okay, so how do you know that it's a good model or bad model? So let's go to the next number here. Good model. Use the regression equation for the prediction only if the graph of the regression line on the scatter plot confirms that the regression line fits the points reasonably well. So hey, first of all, you need to plot this, this two data, and if that is that fits in the scatter, the line, then that is one of the requirement to have the to be a good model. Use the regression equation for the prediction only if the graph of the regression line, the scatter plot, confirms that the regression line fits the points reasonably well. So let's plot this one first. There are other requirements as well, but let's start with this one. If this fails, then you don't have to check this second one or the third one. Okay, so to plot this graph, you can still use the graphing calculator. So you have data. Go first, make your window for x variable and y variable. As you can see that the first data is x value, so you can make window from 0 to, it's going from something, as you can see that the minimum value, all values are positive, and then it's going up to 31, right? Going up to 31. So when you make the window, you can say something 0 to 35, right, for the L1. For the L2, when you try to find the window for y value, it's going from 0 to 5, and they are in 2 decimal place. Okay, so I'm going to choose window for the x value. It's going from 0 to 35, let's say 35. Actual data is going up to 31 only, but I can choose that scale, and my scale for the x value is 1, and for the y value I'm going from 0 to 5. But remember, the scale is, it's a 0.01 because it's a 2 decimal place, so it has to be point 0, it has to be 2 decimal place scale. Okay, enter. Now if you plot the graph, before plotting the graph you have to choose what type of graph you would like to plot. So go second, and then y value. It's going to give you this. Here is the type of the graph you can choose. the graph is the first one. As you can see that here, this is a scatter plot. So choose number one, and it will give you the option. Choose on, and then this is the option we are looking for, scatter plot. And then X value is coming from the list one, Y value is coming from the list two. Mark is, this is the symbol we would like. I don't know. It was taking so long time here. So the idea is you have to put your data here by going here stat number one, and then there is a way to, you know, use your data for list one and list two, and then second and Y, choose number one, and then show number one gives you the plot one, choose on, and then type is scatter plot, and then X value is coming from L1, the Y value is coming from L2, and this is the type of the data, this is the type of the graph we are choosing. And now if you go to the graph, it's going to give you a scatter plot like this. Sometime your calculator might take a little bit time. It's okay. I'm using this wave version, so it was a little bit delay, it was a little bit late. So that's okay. But this is the scatter plot. This is not a line. So scatter plot confirms that as you go here, to be a good model, use the regression equation for prediction only if the graph of the regression line on the scatter plot. So it has to be somehow, a line, but it's not line. Okay, so it's not good model. There are other ways to find out either it's a good model or not, but one region is enough. Okay, you can also find the correlation. You can also choose find out the scope. If all three are not, to be a good model, number two, number three, and number four, that has to be true. Okay, but in this case, in this particular problem, as you can see that, that graph, because of this graph, it's not good model, it's a bad model, so we cannot use this regression equation. Okay, in that case you have to use the tip should be average tip. The average tip you can find if you go to the stat and go to second one, this calculate the one variable stat, that's number one. And if you would like to okay, let me just clear it. Go to stat and go to calc and choose number one variable stat. We would like to find out the average of the tip here, and in our case, if you go back to the stat, we have stored this tip in list 2. So to use that list 2, just go to the second and number 2, that will give you the L2. So I would like to find out the statistics of L2 by using this one variable statistics formula, and when I enter, that gives me average and then standard deviation, everything. In this case I just need average, which is 1.63375. So the best predicted tip for a ride is average of this data, which is 1.63, round to the nearest cent, so it should be 1.63. So that should be 1.63. Yes, so that's the best prediction. How does the result compare to the actual tip amount? So the best prediction is less than the actual tip. So the best predicted value is very different from the actual tip. Yes, that is the right. Let's read the second option. The best predicted value is close. No, not close. The best predicted value is exactly same. No. The result does not make sense given the context of data. No. This is the right one. The best predicted value is very different from the actual tip of 4.7. This actual tip is given here, so we didn't know about actual tip unless it's given here. So for this type of problem, you have to find out either the model is good model or not. If it's not good model, then we use the sample mean as the best predicted value. Okay.